Lesson 5.2, Writing Linear Equations from a Table. Lesson 5.2, Writing Linear Equations from a Table. Example 1, Graphing from a table to write an equation. You can use information from a table to draw a graph of a linear relationship and to write an equation for the graphed line.
You know, lines are all around us in nature and in science. And I thought it would be fun to take a look at an interesting example where we can see nature right on our shoulders and realize that, in fact, lines are everywhere. Let's check it out together. So, this table shows the temperature of a terrarium during an experiment. Our challenge is to graph the data and find the slope and y-intercept from the graph. Then, let's see if we can write the equation for the graph in slope-intercept form. So first, it's a matter of plotting the points. Now, remember how we're going to plot points. The time is always going to be on the horizontal axis, and the other unit, in this case temperature, will always be on the vertical axis. Time is thought of as being the independent variable, and the temperature is the dependent one. So, if we were to graph these points, it would look something like this. And I want us to take a look at this and just confirm this is really how the graph should look. Notice how I've labeled the horizontal axis as time in hours, and the vertical axis is labeled as temperature in degrees Fahrenheit. Okay, and just check out what I did. So I looked at the ordered pair 0, 80. So that's 0, I don't move at all in the x direction, but just go straight up 80. And there's that red dot. Ooh, in fact, I just moved the whole graph. I didn't want to do that. There's the red dot. Now, if we take a look at 1, the corresponding point is 77. So if I'm at 1 hour, then I'm at 77, which notice is just a little bit less than 80. So that seems about right. 2, we graph 74. So 2 is even lower. 3 is 71. So 3 is just above the 70 line. 4 is 68. That's just below the 70 line. And then 5 is 65, which is right in between 60 and 70. So you can see the points plotted. There you go. Now, we're supposed to connect them with a straight line. So let's see if I can do that right now live for you. I don't promise anything. Drawing straight lines is hard. But here we go. I'm going to try it right now live. So I'm going to start here at the 80 point. And, whoops, I moved the whole graph. Sorry about that. Here we go. I'm going to try it right now live. That's not bad. Now, if you have a straight edge, you can even make it better. But, in fact, I'm going to show you an even fancier way of doing it, because, in fact, I did this in advance, and I'm going to show you exactly what I did. And here it comes. Isn't that cool? Don't you wish you had all the fancy stuff that I have? Because there, in fact, is the straight line beautifully drawn. But even a rough sketch is totally fine. But now we can see a fancy one. Okay, now, using this graph, what we want to do is see if we can write the equation for the line. Now remember, the equation for a line is y equals mx plus b. That is the slope-intercept version of the formula for a line. There are lots of different versions of a line, and that's one of them. So, we have to figure out the slope. Now, how can we figure out the slope? Remember, the slope is just the change in y over the change in x. So all we have to do is pick some points and compute this. So how about for one ordered pair, I'll use this point, which remember is, oops, I don't want to use that color though. Let me actually use, I want to use black for these. 0, 80. That's that point right there. And then how about if we use the next point, which is 177, so 1, 77, as the other point. If we use those 2 points, then we can actually compute the slope, because then the slope would equal the change in y's, which would be 77 minus 80, divided by the change in x's, which is 1 minus 0. Really important to remember that if you start with the 77 up front, then that corresponding 1 has to be up front here. If the 80 is the second person, then the 0 has to be the second person here. It's really, really important. It's a classic mistake is to flip-flop them. Don't flip-flop. Okay, now what does this equal? Well, 77 minus 80 is negative 3, and 1 minus 0 is just 1, and so I see the slope is negative 3. So this little calculation using these 2 points allow us to see that the slope of this line is negative 3. By the way, the fact that the slope is negative means that it should be kind of going down, which this one is. So this looks really, really good. Okay, now let's see if we can just clean up our mess a little bit here. We know the slope is negative 3. And so now I want us to write the equation for the line in slope-intercept form. So it's y equals the slope, which we just saw is negative 3, x plus b. And b, remember, is the y-intercept. So what is the y-intercept? Let's see if we can find that by looking at the picture, looking at the graph. Well, it's just where the red line, where the graph crosses the y-axis. And you can see the height it crosses at is 80. So in fact, the b value is 80. The y-intercept is 80. I could even write that down and say that the y-intercept is equal to 80. And we use that fact and we use this fact together to write the equation of the line. Now, this is the equation of the line kind of in the generic way, but given the fact that the x represents hours and the y represents degree in Fahrenheit, you might want to actually write the answer in a kind of a fancy way and say that y, which is just degrees Fahrenheit, is equal to negative 3 hours, that's the time, plus 80. You see, I just replaced the x by h and the y by degrees in Fahrenheit to remind me what the units are. These are hours, and what comes out, in fact, are temperatures. So that, in fact, represents the answer, the equation of the line. So we were able to actually find the equation of the line that models this data of temperature within a terrarium. It's amazing what we can do looking at data graphically, looking at data in a table, and then trying to analyze it. And knowing formulas for equations of lines allow us to actually write down exactly what we see in math terms. So anyway, I hope you have fun with your terrarium. And oh, wait, what? Oh, look, the terrarium must have gotten opened up, and some of the animals got, hello, are you a math? Ow, ooh. Not nice. Have fun with math. I'll see you soon. That was not nice.
Okay, now let's take a look at example 2, writing an equation from a table. The information from a table can also help you to write the equation that represents a given situation without drawing the graph.
Okay, well now let's take some facts and see if we can put them together to actually generate the equation for a line. So here we go. Our mission is to write the equation of the line that passes through the point negative 3, 1, and 2, negative 1 in slope-intercept form. Okay, now one thing we might want to do is just sort of sketch a graph of this and see what, in fact, this line might look like. And I think I'm actually going to do that because it's always sort of a good idea to sort of sketch whenever you can. So I'm just going to do a little teeny picture. It's not going to be a huge picture. Don't worry. I can see already you're nervous. Oh my goodness, he's doing a huge picture. I'm not going to do a huge picture, but it's sort of fun to visualize things, just even informally. So here we're going to go negative 3, 1. So let's just, I'll put in units as I go here. So that's going to be 1, 2, 3, 1. And then 2, 1, 2, negative 1. Okay, and so if I connect those 2 points with a line, we get an informal sense of what the line would do. Look, if you're talking about a line, you might as well at least know what you're talking about. Now, what do we need to figure out to produce the equation of the line? Well, we need the formula for a line, which we're using slope-intercept form, so it's y equals mx plus b. So our job is to find the m, which represents the slope of this line, and the b, which represents the y-intercept. So how are we going to do that? Well, first let's figure out the slope, because we can actually figure out the rise over run. So, what's the slope? The way you calculate slope is to look at the change in the y values, y2 minus y1, over the change in x values, x2 minus x1. So we have 2 points. We've got this point, I'm going to call this x1, y1, and this point x2, y2. So if I insert that in, I see y2, that's the y value, that's negative 1, minus the y value here, which is going to be 1, divided by x2, that's 2, minus the x value here, negative 3. This is so important, I can't overstress this. A great mistake is to switch the order of the x2 and the x1. We always have to decide, this is going to be x1, y1, this is going to be x2, y2, and I'm going to take this minus that, and then this minus that. It's really important. It's easy to get mixed up and say this minus that, and then take that minus this. That's wrong. We always have to subtract in the right order. So you can see right there, there's the x and the y that go together, and there are the x and the y that go together. It's really important. Okay, now on with that, let's go. The top we see negative 2. In the denominator we see 5. And so we see the slope is, in fact, negative 2/5. Okay, great. So I've got some progress here. I see y equals negative 2/5 x plus b. But I still don't know what b is. How am I going to find that unknown b? Well, it turns out that since I'm so close to finding the answer, I must be really, really almost home. What do? Well, I know that both of these points have to satisfy this formula. So let me just pick one of the points. Let me just pick, for example, the negative 3, 1, and plug it in. Negative 3 for x, 1 for y, everything will be known but b. So I can go off now on the side and actually do a little calculation and figure out what b should be. And here's how I'm going to do that. I'm going to now take 1 and plug it in for y, and negative 3 and plug it in for x. And so I see 1 equals negative 2/5 times negative 3 plus b. And so that's 1 equals 6/5 plus b. And I can solve for b by subtracting 6/5 from both sides. And I see 1 minus 6/5. That gives me just negative 1/5. And that equals b. And so I'm able to plug in a point and then solve for b. And once I do that, I see what b equals. And so I see my line is y equals negative 2/5 x minus 1/5. There is the final equation for the line in slope-intercept form. And you can see it was 2 steps. First I had to compute the slope. That was great. Then I took one of the points, plugged it in to solve for the intercept. Now, before I go, let's ask ourselves, does this make sense? I have a little sketch here. Is my sketch accurate? Well, is the y-intercept around negative 1/5? Well, look, if you look really closely, you see this is negative 1, and there's the intercept. It looks like it's sort of a little above negative 1, but negative, and so therefore negative 1/5 looks good. And the line is going downward as the x's get big. It's going down, and so the slope of negative 2/5 seems reasonable. That means that if I go negative 2 in this direction, go down 2, I have to go 5 over. Even my picture seems to indicate that. If that's 2, that kind of looks like 5. So my little teeny silly little sketch seems to be pretty good. It's always good to draw a sketch, carefully think through it, take your answer, go back, see if everything's consistent. Have fun looking at lines written in slope-intercept form.
All right, quick review, lesson tutorial. All right, write the equation of the line that passes through negative 3, 1, and 2, negative 1 in the slope-intercept form. First, we find our slope, and we know how to do that by now. We locate 2 points on the line, and then we simply count the rise and the run. Rise and run. We went 1, 2, down to negative 2, and 1, 2, 3, 4, 5. So negative 2 and 5. And by now we know we can write this as a negative 2 over 5. After that, we want to find the y-intercept. So we're going to use y is equal to mx plus b. We plug in one of the values. Y was 1 and x was a negative 3. Some of us may have issues right there how they come up with 6 over 5. Don't forget that's negative 3 over 1. So there's 2 times a negative 3. That's a negative 2 times a negative 3, which is positive 6. And then 5 times 1 is 5. After that, we solve for b. So b is equal to a negative 1/5.